Okay, so with question 3, we're into thinking about electrons and orbitals and how all those ideas relate to the organisation of the periodic table. So this is a hugely important set of ideas in chemistry and something that's very likely to come up in the exam. So first of all, it wants us just to make sure that we know what the sequence of filling up the subshells is as we go through the periodic table. So use your table, that's the crucial thing, because it acts as a sort of crib sheet to prompt you to get them in the right order. So reading through from the top then, in the first row you just have hydrogen and helium, only 2 elements, because all you've got in the first shell is the 1s orbital, so only 2 electrons can go into it. In the second row we've got 2s being filled up as we go through lithium and beryllium, and also now 2p as well as we go from boron through to neon. In the third row, again we've got 3s being filled up as we go with sodium and magnesium, and then 3p being filled up as we go from aluminium through to argon. And so we come on to the fourth row, and this is where the question kicks in. Beginning of the fourth row we have potassium and calcium, and they're there in the S block, which tells us their highest energy electrons are in an S subshell. And as the question's already told us, that's because first thing that happens as we go across the fourth row is we fill in 4s. Then we come to scandium and we go through to zinc. So suddenly we're into something we haven't had before in the earlier rows, which is a transition series. And remember, that happens because in the third shell we've had 3s and 3p filled, but we haven't filled 3d yet. So what's happened as we go from scandium through to zinc is that we're filling in the 3d subshell. So that's what comes next. So in the question we've got all those being filled up as far as 4s, and then the ones we've got to fill in, the first one is 3d, and that has 10 electrons that can go into it because there are 5 d orbitals in a subshell, and that corresponds to the 10 elements through as far as zinc. And then we're back in the p block. Remember, this block over here is called the p block because the highest energy electrons are in a p orbital. And so that was filling up 2p, that was filling up 3p, so now we're filling up 4p is the other answer that it wants there. Okay, next it wants a definition of an orbital. So an orbital is a region of space which can contain up to 2 electrons with opposite spins. Again, straight out of the definitions list. But it's an important idea, it's a region of space. Remember, it's not a path, it's not an orbit. Anything that implies that you think the electron goes round in some regular path, that's what will lose you marks. The idea is all you can do is describe a region of space where the electron is most likely to be, and that's all you can say. So a region of space which can contain up to 2 electrons with opposite spins. Okay, and now it wants to know the total number of electrons occupying the p orbitals in a chlorine atom. So here's chlorine in your table, it's in the third row, just one ahead of argon there. So remember that the p subshell can contain 6 electrons, and that's reflected in the 6 elements in each little run as you go across the p blocks here. So 2p has already been completely filled before we reach to chlorine, so that gives us 6 slots of p electrons as we've gone across there. And then in the third row we've again now started filling up the 3p subshell, but we've not got all the way across, we've only got to the 5th one across there, so there are 5 p electrons there, and that gives us a total of 11. Okay, so the answer is 11 electrons in p orbitals in a chlorine atom. Calcium 2+, how many electrons are there in an ion of calcium 2+? Well, the easy way to do that one, we don't really need to think about orbitals for that one. The easy way is just to look at the atomic number of calcium is 20. Remember, it's the number at the bottom of the square. And that tells us that a calcium atom would have 20 electrons. So calcium 2+, the 2+ means it's lost 2 electrons. And so the answer is that it has 18 electrons. It's very important you remember that the plus means it's lost electrons, because electrons are negatively charged things. So if you take, every time you take one away, the thing becomes more positive. So 2 plus means 2 fewer electrons than it would normally have, so 18. And then we get to the successive ionizations of aluminium. So the key for this is to make sure that you get the electron configuration right. And again, the periodic table is the key to that, really. So here's aluminium, which we've already marked on there. So always with questions like this, I would begin by just scribbling down the electron configuration of that element. And we can do that with the aid of the table. So we've got 1s2, 2s2, 2p6 as we go. 2s2, 2p6, and then 3s2 and 3p. Well, it's the first element in that 3p subshell, so it's just 3p1. Okay, now when we do ionization, remember that you always start with the highest energy electron, because that's the one that's already got the most energy, so it needs the least extra energy in order to give it enough to escape. So the one that has the highest energy already, which is 3p, will be the easiest one to ionize. So loss of that one will be the first ionization. Then the second and third will be the loss of those two in 3s. And what we're being asked for is which ionizations correspond to removal of s electrons. So those ones, 2 and 3, fall into that group. Then we go back again, and now we're emptying 2p. And there are 6 electrons in there, so that'll be 4, 5, 6, 7, 8, and 9. All coming from 2p. Now there are 2 electrons coming out of 2s. So that will be the 10th and 11th. And again, those are s electrons, so those are the ones we're interested in. And the final one, or final 2 rather, will be the 1s electrons. So the 12th and 13th ionizations will come from 1s. So those are the 12th and 13th, like that. So the question said, state all the ionization numbers that involve the removal of an electron from s subshells, and the answer is 2 and 3, and 10 and 11, and 12 and 13, corresponding to 3s, 2s and 1s. And finally, it wanted the equation that represents the third ionization energy of aluminium. So third ionization means it's already lost 2 electrons. So the starting point is aluminium 2 plus. Okay, it's very important to remember that ionizations are always about removing 1 electron at a time. So if it's the third ionization, it means 2 have already gone, so the starting point is 2 plus. And it says it wants state symbols, and remember, ionization is defined as the energy required to remove an electron from each atom in a mole of gaseous atoms of an element. So gaseous is the key there, means you've got to have that state symbol. Doesn't matter that aluminium metal isn't a gas, we're not ionizing it from the metal, we're ionizing it from, well, gaseous 2 plus ions in this case. And the third ionization just corresponds to knocking another of its electrons out, so it will go to aluminium 3 plus, still in the gas phase, plus the electron which you write as E minus. And that's it. End of question.